Hello class, welcome to PsyChem. Here we are another session for new chapter is phase equilibrium. So new chapter is phase equilibrium. Normally equilibrium is of three types: it's chemical, another is ionic, another is chemical ionic equilibrium. We have already studied in previous semester, but we are now going to deal with phase equilibrium. So before starting phase, what are the classification regarding chemical ionic? If electrolytes are strong, then we are studying chemical equilibrium. If electrolytes are very weak, then we are studying ionic. If electrolytes are neither very strong nor very weak but moderate in nature, then we are studying phase equilibrium. So these are the classification that depends upon the nature of electrolyte. So before starting phase equilibrium, we have to know what are phase. The basic concepts are phase, component, and another part is DOF, degree of freedom. So these are the basic three part of phase equilibrium. So starting from phase, before knowing the term phase, the basic term phase, we have to know what is the basic difference between phase and state. What is the basic difference between phase and state? So let us consider we have a system. These dotted lines represent water, liquid, and above it the spherical molecules are. That means we have a system that involves oil plus water, and these oil plus water, these substances are immiscible. So in order to know the basic difference between phase and state, I can simply say that oil is in liquid state, water is in liquid state. So here in this oil water system, state is equal to 1. That means one state. But phase is equal to 2. How I came to know that phase is equal to 2? That means here is a small boundary separation, that is imaginary boundary separation between oil and water. So oil is one phase and water is another phase. So phase is 2. So how can I know difference between phase and state? Simply remember, state represents physical appearance. State represents physical appearance, but phase represents boundary separation. So state in this oil water system, one state means oil is in liquid state, water is in liquid state, so they have physical appearance liquid state. But in case of phase, we have two phases, because in between oil and water there is an imaginary boundary present. So So as there is a boundary separation, I can simply state that there are two phases are present. So what are characteristics of phase? So what are the characteristics of phase? So the first characteristic is phase is homogeneous throughout system. Phase is homogeneous throughout the system. That means since here oil and water system, oil is in liquid state, water is in also liquid state, so liquid plus liquid, that means the phase is homogeneous. Another main characteristic is phase can be physically distinct. Either we are using liquid or solid liquid, so they can be physically distinct or physically divided. Next part is phase can be separated by boundary. Phase can be separated by boundary. And another part is important. Phase can be separated by boundary. A boundary is of two types. One is real, another is imaginary. So real boundary, consider a system. Here is block A, here is block B. In block A, I put here water. In block B, I put here oil. And these two are separated by a boundary. So this is our real boundary. But if I open this boundary, if I remove this boundary, then the system is like this. So well, they are immiscible liquid, then there will be a imaginary boundary. And phases can be, another important point is phases can be mechanically separated. Phases can be mechanically separated. So these are all basic things about phase. So we have discussed what is phase, and now we are going to discuss about the definition of phase. So a phase is that portion of a system which is homogeneous throughout in composition. A phase is that portion of system which is homogeneous throughout in composition, and they have following characteristics. They are homogeneous throughout system, physically distinct or physically divided. Phase can be separated by boundaries, and phase can be mechanically separated. Mechanically separated means we can use fractional distillation, crystallization. By using fractional distillation or crystallization, I can separate the phases. So these are all regarding basic concept of phase. So how to calculate phase? Before calculation of phase, we are going to study mixture. So one mixture is liquid mixture. Liquid mixture, here is another condition. If we are taking miscible liquid such as water, alcohol, then in that case phase equal to H, both water and alcohol mix with each other. In that case the phase equal to 1. But if we are taking immiscible liquid such as oil plus water, So in that case there will be phase equal to, that is important. So in case we are taking immiscible liquid, so I can simply write in general number of phase equal to number of immiscible. Another type of mixture is solid liquid. So solid liquid, there is also two cases: solid dissolved in, consider NaCl. If you add NaCl to water in this system, this is homogeneous. So here phase equal to 1, phase equal to 1. If solid not dissolved in water, I can write Fe plus H2. Fe is solid. So this is one phase, it is another phase. So here phase equal to 2. Another type mixture is another type of mixture is solid. This is an example of LOA. Here phase always equal to 1. Another type of mixture is gas. Since all gas mix with each other, so here phase is equal to 1. Gas liquid mixture, consider O2 gas dissolved in H2O. O2 gas dissolved in H2O. In that case phase equal to 1. But if there is given O2 and water, in that case phase equal to, because O2 is a gas, water is a liquid. If they are dissolved, then phase equal to 1. If they are given variable, if they are given in different manner, then that will be phase equal to 2. So in order to know the phase, we have to deal with what type of mixtures are present. So first we have liquid. If there are miscible liquid, then phase equal to 1. Immiscible liquid, phase equal to 2. Another part, solid liquid. If the solid is dissolved in any solvent, then that case phase is 1. If the solid is not dissolved in water, then the phase is 2. Solid always phase equal to 1. Gas phase equal to 1. Gas and liquid. If O2 is dissolved in water, then the phase is 1. But O2 and water are present in different manner, then phase equal to 2. So we are going to now calculate number of phase. So consider H2O solid. If we are considering H2O solid, that means here phase equal to 1. If we are considering H2O liquid, here also phase equal to 1. If we are considering H2O solid is in equilibrium with H2O liquid, that means solid and liquid phase equal to 2. Solid and liquid. If there is given, consider question number 3, Ag plus Cl minus if any question is given like this, you have to consider that AgCl is completely dissolved in, if AgCl is completely dissolved in water, so I can simply say that phase equal to, if in another type question there is given like this AgCl, Ag plus Cl minus water, that means in a solution the species are present, that is AgCl, Ag plus Cl minus, that means here AgCl is partially dissociated. Since AgCl is partially dissociated, that means AgCl solid is present, water is liquid, Ag plus Cl minus equals, so here phase is 2. Let us consider another case. Calcium carbonate dissociate calcium oxide plus carbon dioxide. Calcium carbonate is solid, it is also solid, it is also gas. So in order to calculate phase, calcium carbonate partially dissociated, so it is one type of solid, it is another type of solid, it is gas. That means here phase equal to 3, phase equal to 3. If there is another type of, if consider another type of question, if there is a given question like this, Ag solid plus water, then here also phase equal to, because silver, Ag silver, water, they don't dissolve, so phase equal to 2. Consider a system containing A gas, B gas, C gas, D gas, E liquid, F solid, G solid. So calculate phase for this system. How many phases are there? Since gases combine with each other, they don't react, but they combine with each other and they have homogeneous phase. So here the 4 gases are in one phase, liquid is another phase, one phase, it is also one phase, it is also, so total phase equal to 4. So for this system phase equal to 4. If I am given a diagram like this, consider C2H5OH is present. Here CCl4 is present, and here water is present. Phase, calculate phase. In another case, C2H5OH, here calculate. Please pause the video and think yourself. So since CCl4 is non-polar and it does not dissolve in water and C2H5OH, so there is 3 boundaries are present, one for water, CCl4, so here phase equal to, but here the C2H5OH and water dissolves and these are miscible liquids, so these two will form one phase and this one will another phase. So here phase equal to 2, phase equal to. So these are all about phase, and we can have a clearly idea about how to calculate the phase in a system. Next, come to another part, the important part. So we have completed this page. Now come to important part, component. Component. Before starting component, we have to know what is the difference between number of constituent and number of component. Number of constituent and number of component. So number of constituent means number of species present in a system. Number of constituent means number of species present in a system. Simple. Let us consider a reaction, dissociation of calcium carbonate, and that will give carbon dioxide and calcium oxide. It is solid, gas, solid. So if we consider the system, here the one species is calcium carbonate, another species is carbon dioxide, another species is calcium oxide. So here phase equal to 3 and number of species equal to, it is considered phase 1, 2, 3. So number of constituent means number of species present in a system. Now what is number of component? So number of component means smallest number of constituent required to define phase in system. This definition is a little bit tricky, but you have to consider this definition and you will be understanding later. But you have to consider this, that smallest number of constituent required to define phase in a system. I am giving an example. Again consider so in this case phase is 3, number of species is 3, or number of constituent equal to 3. So this is our phase 1, this is our phase 2, this is our phase 3. Phase 1 involves calcium carbonate, 2 involves calcium oxide, and 3 involves carbon dioxide. So in order to define this phase or this phase, I need a minimum number of constituent. In order to define this phase and this phase, I need a minimum number of constituent, and this minimum number of constituent is called number of component. If I consider here, if I consider calcium oxide and carbon dioxide as minimum component, minimum number of component, calcium, carbon dioxide and carbon dioxide. by using calcium oxide and carbon dioxide, if I can explain the phase, then it is our minimum number of component or component number equal to 2. How? Let us consider. Here, in order to explain this phase 1, I can simply write CaO plus CO2. CaO CO2 react together to give calcium carbonate. In order to explain phase 2, I can simply write calcium oxide plus 0 carbon dioxide. In order to explain phase 3, I can write 0 calcium oxide plus carbon dioxide. So calcium oxide and carbon dioxide are the you have to consider are the minimum number of component, and by using this minimum number of component we can easily explain the phases. If you are not in favorable if you are not in favorable for condition for calcium oxide and carbon dioxide, then you can consider calcium carbonate and calcium oxide. Consider this is your minimum number of component. If this is our minimum number of component, so I can simply write here calcium carbonate plus 0 calcium oxide. By using this minimum number of component, I can explain phase 1, phase 2, phase 3. For phase 1, I am writing here calcium carbonate plus 0 calcium oxide. For phase 2, I am writing 0 calcium carbonate plus calcium oxide. For phase 3, I can write calcium carbonate minus calcium oxide. If I minus calcium oxide from calcium carbonate, I will easily get carbon dioxide. If you are considering calcium carbonate and carbon dioxide as minimum 2 components, so I can write here calcium carbonate plus 0 carbon dioxide, and this is calcium carbonate minus carbon dioxide, and this is calcium carbonate plus CO2. So by using a minimum number of component, I can easily explain each of the phase. So smallest number of independent constituent by means of which, if I can easily explain the composition of various phases, if I can easily explain, and again, if I can easily explain the composition of various phases by using a minimum number of constituent, then that is called number of components. So here, smallest number of independent variable constituent by means of which composition of each phase can be expressed directly or in terms of chemical equation. Smallest number of independent variables or constituents by means of which composition of each phase can be expressed directly or in terms of chemical equation, that is called number of component. So for component, we have to consider what are the smallest number of constituent. Here we are taking calcium oxide and carbon dioxide. No doubt in this equation we have 3 species. 3 species means 3 constituent, but apart from 3 constituent, we are considering only 2 constituent, that is calcium oxide and carbon dioxide. If we are considering calcium oxide and carbon dioxide as 2 constituent, then we can, by using calcium dioxide and carbon dioxide, we can easily explain the composition of phase 1, phase 2 and phase 3. If we are considering calcium carbonate and calcium oxide as minimum number of component, also we can easily explain the composition of phase 1, phase 2 and phase 3. So number of component may be defined as the minimum or smallest number of independent variable constituent that are required to express the composition of each phase. which can be expressed directly or in terms of chemical equation. No doubt this definition is a little bit tricky, but this definition is more trickier than this. So here it is defined as the minimum number of independent and constituent species whose composition has to be defined so that the composition of all species present in system can be expressed directly in terms of. So these are all basic things about components. If I am considering sugar solution, if I am considering sugar solution, sugar solution means I am taking here sugar plus water. So here is equal to and number of constituent or species is 2. One is sugar, another is water. So in order to define the composition of phase, this phase, I need the smallest number of variables. And what is the smallest number of constituent I have to consider for define the phase? That is, one is sugar, another is water. So here component is 2. That means it is 2 component system. The minimum number of constituent I required is one is sugar, another is water. So that is, in order to define the phase, we have to consider 2 component system. So how to calculate number of component? In order to calculate number of component, if we have two conditions, if we have non-reacting species, we can consider number of component is equal to number of species. If we have non-reacting species, we can consider where C is number of component, and number of component is equal to number of species. If we have reacting species, then though we have to calculate number of components, C is equal to n minus E minus R. What is the meaning of n? Where n is the number of species, E is one condition for equilibrium, is a condition for equilibrium, and R is restricted condition. R is restricted condition, or R is a relation among. So we have two formula for calculate number of component. If there is a non-reacting species, so I can simply write C is equal to n. Number of species is equal to number of constituent. If we have reacting species, then we have to use C is equal to n minus E minus R, where n is the number of species, E is equilibrium, how many number of equilibrium reactions are involved, and R is the restricted condition. And this is the formula by we have to use in order to calculate the number of components. So let's start to calculate the number of component. So first we have question 1, H2O solid. For H2O solid we have phase equal to 1, so component is equal to also, that is one component system. If we are considering water solid is in equilibrium with water liquid, water solid and is in equilibrium with water liquid, these are two non-reacting system. I can simply write here number of species is equal to 2, one is water solid, another water liquid. So I can use the formula number of component is equal to n minus e minus r, where n is number of constituent and e is the equilibrium relation. There is one equilibrium present and that will be equal to 1, and r is restricted condition or relation among species. There is no relation, so r tends to 0. So c is equal to 2 minus 1 and that is 2. I am doing as many age problems to calculate number of component so that you can easily understand what is component and how it can be calculated. Just observe the problems. Another consider water solid is in equilibrium with water liquid, that is also is in equilibrium with water gas. So number of species n equal to 3. Since number of species n is equal to 3, so we have formula C is equal to n minus e minus r. C is equal to 3 minus e. There are two equilibrium reactions are present, that will be equal to 2 minus 0. So it is also one component. Another problem I am doing, NH4Cl solid dissociates NH3 gas plus HCl gas, and there is a condition is given, pressure of NH3 equal to pressure of HCl. So total number of species is equal to 3 and we have to calculate number of components. C is equal to n minus e minus r. So C is equal to number of species 3 minus 1 equilibrium is present here minus restricted condition, given condition PNH3 is equal to PHCl and that will be equal to 1. So it is 1. So this is also one component system. If the condition is not given, then r will be tends to 0, n minus e minus r, and this r tends to 0. Then C is equal to 3 minus 1, that will be equal to 2. That will be 2. So this is all about number of component calculation. Thank you for watching. In next class we are going to deal with a lot more problems about